When you think of it, it boggles the mind. Oil and gas have been beneath the oceans of the world for millions of years. Man has known of their existence for perhaps a couple of hundred years. But the actual development of the ocean's vast hydrocarbon resources has only taken place over the past 50 years. In terms of time, the modern offshore industry can be related to man's conquest of space. Everything is happening at supersonic speed. Every second of every minute of every day, millions of tiny sea organisms are born, live their lives, and die, an endless biological evolution. When they die, they sink to the bottom, forming layer upon layer of organic matter. Meanwhile, tons of sand and silt pour from the land, carried by rivers and streams, and spread to form a blanket of rock over the ocean floor, burying and compressing the rich biologic organic sediments. Finally, the organic matter is buried so deep that pressure and the Earth's natural heat convert into droplets of oil or molecules of gas called hydrocarbons. They are squeezed from their source beds like liquid from a sponge, and because they are lighter than water, start to float upwards. The microscopic droplets of oil find paths through cracks in the rock or between the grains of sandstone. As they migrate upward, they coalesce with other droplets to form a volume of oil. Sometimes the oil finds a natural path up to the sea bottom and releases into the water where it floats to the surface. The oil from these natural seeps washes up on beaches and contributes to the tar we sometimes find on our feet or bathing suits. Seepage is natural and has taken place for millions of years. But most of the oil remains trapped in the sediment below. It becomes trapped beneath impermeable rock and forms what is called a reservoir. There it waits for millions of years until man discovers it and realizes what a treasure he has discovered, an unprecedented natural resource for energy and materials. It is not clear when oilmen first realized they could site their rigs on other than dry land. In the 30s, rigs placed on rickety piling started appearing in Venezuela and in the shallow waters of the Caspian Sea near Baku. In California, drillers experimented with land-based rigs to drill slanted wells under the Pacific to extend prolific coastal fields. But it was in 1947 that the first truly offshore well was drilled. Defined as the first well drilled out of sight of land, the #1 Point Ophir well was drilled for Kerr-McGee Oil Company 12 miles offshore Louisiana in 18 feet of water. The development of an offshore field is a complex activity employing thousands of highly skilled workers using space-age technology. First, seismic maps are made of the Earth's structure to a depth of several miles. To do this offshore, data are gathered in specially constructed vessels packed with sophisticated computer equipment and towing long lines containing listening devices called hydrophones. These detect echoes of seismic signals bounced off subsurface strata, allowing physicists to create maps showing the locations of promising formations which could trap oil or gas. Technology has evolved over the past decade from gathering and processing 2D, 3D data, which geologists and geophysicists interpret to generate prospects. Other tools include sensitive gravimeters that measure variations in the Earth's gravitational field over oil deposits, or highly accurate thermometers that detect the upwardly migrating oil. Once a prospective drilling location is decided, an exploration drilling rig is brought in to drill a wildcat well. Rigs used for exploratory drilling are movable, called MODUs, mobile offshore drilling units. There are several types of MODUs used to explore for oil and gas according to water depth and the ocean's environmental forces. Submersibles can float to location and then are ballasted to bottom to form a stable drilling platform supported by the ocean floor. When the well is completed, the hull is refloated by pumping out ballast water and the rig is towed to the next location. Submersibles can work in shallow water depths averaging about 50 feet. Jackups, like the Ocean Star, have 3 or more long legs that reach to bottom. They move under their own power or can be towed to location. Once at the drill site, jacking mechanism pushes the legs to bottom, continue until the entire rig hull is jacked out of the water safely above the highest waves. The largest jackups can work in waters up to 400 feet deep. In very deep waters, floating semi-submersible rigs or drill ships are used. Semi-submersibles are supported by huge pontoons far beneath the sea surface and are thus subjected to less wave action. These giants can have deck areas larger than 3 football fields. They are extremely stable, even in the harshest weather, and can be kept on location by a system of anchors or computer-controlled 360-degree swiveling thruster propellers below the pontoons. In ultra-deep waters, thruster propulsion only is used because mooring lines would cause too much stress. This is called dynamic stationing. Drill ships have ship-shaped hulls with the rig derrick mounted amidships. Drilling is conducted through a special opening in the hull called a moon pool. Drill ships can be moored or use thrusters for dynamic positioning. A scientific drill ship, the Sedco BP-471, currently holds the record for deep-water ocean bottom coring, 19,614 feet. Once the MODU has drilled a discovery well, it is used to drill 1 or more delineation wells to determine the area, extent, and volume of the reservoir. Often, neither the discovery wells nor the delineation wells are ever produced, because it is determined that the reservoir can be most economically developed from another, more central site. Supporting the drilling operation is a virtual Army, Navy, and Air Force of well service companies, boat companies, helicopter and communications companies. Directional drillers help steer the wells precisely to their targets in the reservoir. Well service companies use sophisticated tools to take geological measurements that answer the oil company's questions. Is there oil? How much? And will it produce? Other companies install casing and cement it in place, install completion equipment valves and flow lines to tie the wells back to the production facility. When the oil company is convinced that sufficient hydrocarbons to sustain production have been discovered and the reservoir boundaries delineated, they decide on a production scheme. Because offshore installations are so expensive, amounting to hundreds of millions of dollars, the usual technique is to drill and produce all the wells from a central location. To enable the drilling of several wells from a single platform, offshore drilling engineers developed and perfected the technique of directional drilling. Now, wells can not only be drilled directionally, they can be steered precisely into the target reservoir, maximizing recovery from the field. Traditionally, jacket platforms are constructed and fixed on the ocean floor. These support 1 or 2 drilling rigs and production equipment for the many additional wells that will be needed to fully exploit the reservoir. Jackets are constructed lying horizontal in a shipyard. Then they are skidded on flat barges and towed to location. By strategically flooding and debalancing tanks in the hollow legs, the huge structure is tilted and sunk precisely into place. A deep-sea crane bar installs the topsides modules containing drilling and production equipment and living quarters for up to 200 workers. Oil is transported to shore by pipelines or by shuttle tankers. From initial discovery to production can take several years and cost hundreds of millions of dollars before the first barrel is sold. The offshore industry has spawned new technology, innovation, and mammoth construction projects. As water depth increased, engineers looked for new ways to design the structures they needed. Concerned that freestanding jacket platforms require increasingly massive bases in deeper waters, they designed a compliant platform which would sway in the ocean currents, but was held vertical by a system of guy wires. Shortly afterward, the tension leg platform was introduced that is anchored to the ocean floor, but has positive buoyancy, so it is always held at a fixed distance from the seabed. This keeps the column in tension and gives it stability. Spar platforms are giant vertical tanks held in place by tenons. The rig, production, and living quarters modules are attached to the upper end. Production can be stored in the spar until it can be transported to shore. But the biggest platforms are the giant concrete gravity-based structures. Troll, in the North Sea, is taller than the tallest skyscrapers. And Hibernia, soon to be installed in Newfoundland, has a huge iceberg shield capable of fending off a 600 million-ton iceberg. The Ark has challenged the industry for many years. Man-made drilling islands are constructed to support the rigs and deflect the constantly moving sheet ice. Brazil and the North Sea have led in the development of subsea production systems, whereby wellheads are set on the sea floor and produce their oil through umbilical cords containing all the hydraulic and electrical control cables, as well as the flow line. The giant Terra Nova project offshore Newfoundland will use subsea wellheads to avoid floating icebergs in the area close to where the Titanic was struck. Oil will be pumped into a disconnectable storage vessel, which can move out of harm's way if an iceberg comes. An entire industry of tankers, buoys, and special-purpose vessels has been born to handle offshore production. Where possible, a network of pipelines brings oil and gas to shore. Alternatively, production can be stored on special floating, production storage, and offloading vessels, FPSOs, which are serviced by fleets of shuttle tankers. These have the ability to begin processing of the crude oil, separating unwanted water or paraffins. High-speed transfer of oil to tankers is completed through single-point mooring system buoys, which swivel to accommodate wind, current, and weather. The Offshore Energy Center is dedicated to honor the past, but also to preserve the future. As you visit the center, you will see how offshore oil and gas are discovered, how wells are drilled and produced, and how the oil and gas gets to the consumer. You'll also see the newest technology, from platforms taller than the high buildings to subsea wells serviced by robots and operated by remote control. Most importantly, you'll see how the men and women of the offshore industry never take shortcuts where safety or preservation of the environment are concerned. And you'll see how the worldwide development of our offshore oil and gas resources represents the triumph of those tireless, dedicated, and innovative pioneers who dared to test the forces of nature and take the industry to sea.